Hello dear students, this is Dr. Saurabh Sir's classes. This is our contact number which is 9836793076. Again I am repeating it, 9836793076. This is our contact number. Please feel free to ask any doubt, any questions and anything in this number, and we are going to start a batch that will help you in the logical thinking and for your mathematical bag to strengthen your mathematical backgrounds. Okay, so we are doing the previous year question which is from our TIFR GS 2025 questions. So this is given this question appeared in that examination, so we are going to solve it. So now the question is telling us that let f be a function which is running from closed 0 1 to r be such that fx equals to 1 by 2 to the power n if our x is equals to p by 2 to the power n, where p is an odd integer and our 0 otherwise. So which of the following statements is correct? Option A is telling us that f is continuous at x belongs to close 0 1 if and only if x is rational, and our option B is telling us that f is continuous at x belongs to closed 0 1 if and only if x is irrational. C is telling us that f is not continuous at x for any x belongs to the closed 0 1, and none, and option 4 is telling us that none of remaining three statements is true. So we can see that this function is told as raindrop function or Thomae function. We know that Thomae function. Okay. So there are some properties of it, but I want to do the question in very vague way. So we are analyzing the function which is this, and we aim to determine at the points of discontinuity of f on the closed interval 0 1. Okay, so step 1, we are going to understand the function. So the value fx equals to 1 by 2 to the power n occurs only for x which is on the in the form of p by 2 to the power n, and our p will look like 2n plus 1 where our n is belonging to z. Okay, so these are the dyadic rationals with odd numerators. So for all other x irrational numbers and rationals which is not in the specified form, then our fx will be 0. So now the continuity at a point x belongs to closed 0 1. So to check whether f is continuous at a point x, recall that our f is continuous at x if what will if our limit x dash tends to x, our f of x dash will be fx. So now case 1, for the case 1 we will take our x in the form of p by 2 to the power n, and our p is odd number and etc. So if our x is equals to p by 2 to the power n, then our fx is 1 by 2 to the power n. So now consider the behavior of fx dash as x dash tends to x. Near x, there are infinitely many x dash, irrationals or rationals not of the form of p by 2 to the power n, where our fx dash will be 0. Thus the limit x dash tends to x if x dash be 0, which is not equal to 1 by 2 to the power n. So hence our f is not continuous at the points x equals to p by 2 to the power n. Okay, not continuous. Okay, so now we are going to see about the other case. So where our x is not in the form of this. Case 2. X is not equals to p by 2 to the power n. Then what will happen? Then if our x is not in the form of p by 2 to the power n, then fx is equals to 0. And consider the behavior of fx dash as x tends to x dash, x dash tends to x. For any neighborhood of around x, there exist points x dash from of the form p by 2 to the power n, where our fx dash will be 1 by 2 to the power n. So this implies that our limit x dash tends to x if x dash is not equals to 0 equals to fx. So our f is not continuous on this thing also. So the function fx is not continuous at any point of x. And there exists 0 and 1 sorry, on close 0 1, because the limit of x dash tends to x fx f dash sorry, when the limit, I am writing it, never matches fx regardless of whether x is rational or irrational. So the correct choice will be none of the remaining three statements is true. So the correct answer of this question will be our option D. Hope you understood the question and understood the explanation also. Thank you. But again, I am telling that please feel free to call on this aforesaid number, which is 98367930076. We will help you in the various way, in the various manner of the mathematics and etc. So please feel free to call on this number and enjoy the services of Dr. Saurabh sir's classes. Thank you, students.